Hello and welcome to this new tutorial about Syntonis GNSS simulator Constellator. Today we will focus on the device description. In this video we will introduce you to the Constellator setup, and we will also stop a moment on the Constellator hardware and describe its various interfaces. The Constellator setup consists of a main platform called the server that plays simultaneously the role of the big computation unit and the RF signal generator. It embeds a specifically designed motherboard to generate IQ values at high speed and an RF block to convert them into GNSS signals. As you can see on the front face, the TX board provides 3 independent RF outputs plus 1 combined output. To configure and monitor your simulations, Constellator provides a clear and straightforward graphical user interface. This HMI is a window application independent from the server. This means that you can install it on your personal laptop and control simulator from anywhere as soon as both your computer and the server are connected to the same network. Once your GUI connected to the server, you're pretty much ready for your testing session. You can now plug your favorite GNSS receiver and launch the simulation. The front face of the Constellator is pretty neat. It consists only of one button, the power button, and 4 RF outputs. Nothing particular to say about the power button. Anyone can quickly figure out how it works. The only noticeable thing is about the background LED, indicating if the Constellator is powered or not. Now let's talk about the RF board. Constellator provides 4 RF outputs, all being available on the front face of the equipment. Constellator provides 3 main RF outputs implemented through SMA female connectors. Each of them broadcasts a subband usually reserved for a specific frequency or a specific antenna. The user can configure the frequency or the antenna broadcasted on each output according to his needs, but by default, it would be all L1 signals on output number 1, all L2 signals on output number 2, and all L5 signals on output number 3. The fourth RF output below, implemented by a Type N female connector, broadcasts the combined signal of all 3 defined RF outputs. The RF boards can broadcast on a frequency range spreading from 1100 MHz to 1600 MHz to covered L bands, and from 2400 MHz and 2500 MHz to cover the S bands. Constellator can handle all of the most common GNSS bands from L1 to S. Please note that the power of broadcast signals on the RF outputs are about 68 dB higher than the real ones you can receive with your antenna. So Syntonis advises to use a 60 dB attenuator between your Constellator and your favorite receiver. The back face of the Constellator is a lot more crowded than the front face. Let's start from left to right. On the very left you have 3 items related to the power supply: the connector, the power switch and the fan. Then you've got the 4 BNC female connectors, each dedicated to the specific use. The first one, on the top left, is reserved for external 10 MHz input. It is used when you want to synchronize a clock of your Constellator with the one of an external source. The second one, in the top right, is reserved for the internal 10 MHz output. It is used when you want to use the clock of your Constellator as a clock reference for other equipment. The third output, in the bottom left, is reserved for the PPS-in signal, used to synchronize the Constellator with an external PPS source, PPS standing for pulse per second. The fourth one, in the bottom right, is reserved for a PPS out. It's used to synchronize other equipment thanks to the PPS out of the Constellator. Continuing on the left, you got the serial COM I/O and the JTAG connector. The JTAG plug, a sub D9 female connector, is used to program the FPGA of the machine. Then, on the right of the back face, you got the interfaces connected to the motherboard. On the top, you've got 2 BNC female connectors to handle the trigger mechanism. On the left, you got the Trig IN/OUT plug, used to synchronize other equipment with the trigger emitted by the Constellator. Constellator is here used as a master. On the right, you got the Trig IN plug, used to synchronize Constellator with the trigger coming from an external source. Here, Constellator is considered as a slave. On the bottom, you got 2 USB 3.0 connectors and 1 VGA video output. In addition to this, there is 2 RJ45 Ethernet connectors. These 2 plugs have very specific purpose. The first one on the left, with the HMI sticker, is used to connect your Constellator to the computer that hosts the GUI. You can either connect directly your HMI computer to this interface or simply plug it on a shared Ethernet network. The other Ethernet interface is reserved for the hardware-in-the-loop feature. Hardware-in-the-loop is a specific feature that allows to inject a receiver trajectory to simulate in real time. Finally, one additional Ethernet interface may be added to your backface as an option, the one handling the parent link. These also use a RJ45 Ethernet connectors, but the motherboard is linked to a 10 GB Ethernet card. Parent server is an option that allows the user to set a specific parent code for a given signal, very useful to test specific military codes. Both parent servers and hardware-in-the-loop features require to code a client application for hardware-in-the-loop or a server application for parent server. The expected format and communication protocols are defined in dedicated documentation. Note that all front faces are identical, but back face may change according to the Constellator model you got. That said, you shall be able to retrieve and identify all the items described earlier thanks to the type of connector and the sticker added on the panel.